we have the equation for the energy that says E times VO equals HF minus phi, which is the work function. And so we can say that the voltage is equal to H over E times F minus phi over E. And in this case, we can see that the slope of the line, if we consider this to be a linear, then the slope of the line is given by H over E, and the vertical intercept is minus phi over E. If we look at the frequencies of F equals C over lambda, we can get that we have a few different lambdas, which gives us frequencies of 3.00 10 to the 8th meters per second over the first frequency of 600 times 10 to the minus 9 meters will give us a frequency of 0.5 times 10 to the 15th hertz. We can have another frequency of corresponding to the 400 nanometer. Will give us a frequency of 0.75 times 10 to the 15th hertz. And finally, we have a third frequency for the 300 nanometer, and hopefully that's easy to see that it's 1 times 10 to the 15th hertz. So we can say that minus the work function over E then is minus 1.05 from the graph in the book, or we can take a look at a table that gives us the vertical intercept, or we can graph it ourselves and see. So either way we can get that, and from here we can get that phi then is going to be 1 EV, or 1.6 times 10 to the negative 19th joule. And then we have the slope of which can be given as delta V naught over delta F. And if we consider 3 volts minus a negative 1 volt over the change in frequency that corresponds to those two voltages, we get 1.0 times 10 to the 15th hertz minus when the voltage is negative 1, we don't have a frequency corresponding to that, and we get about 4.0 times 10 to the negative 15th joules second per coulomb. The slope is related to h by h equaling slope times e, which means we have 4.0 times 10 to the negative 15 joule second per coulomb times 1.6 times 10 to the negative 19 coulomb, or this gives us 6.4 times 10 to the negative 34 joules second. Now, just want to mention that the graph that we were using is the stopping potential. As a function of frequency. So if you look that up, you can see the values that I've used in here.